23 design patterns that you will mostly never use. This is a little bit misleading because actually some of these design patterns are incredibly useful. But what I actually mean is, when you think about design patterns, I don't generally go about it and look at some code and think, oh, this is a job for the mediator, or oh, this is a job for a builder or an observer. But by reading through some of the way that design patterns are laid out, what it actually does is it sort of helps me when I'm writing my code. And if I look back at some of the code that I've written with retrospect, I would naturally start seeing things like these design patterns occurring. Now, these patterns were taken from the Gang of Four book, which is probably about 25, maybe even 30 years old now. And the interesting thing about that is that after those 30 years and lots of different iterations on languages and computer science thinking, quite a lot of them are still very relevant. So again, don't dwell on the names of these patterns. Don't think, oh God, I'm never going to be able to remember that. But spend the time to look over them and to examine how they work, and just let them passively sink into your brain, and it will make your code a lot better. So the mediator pattern, this is the first one I want to talk about. And the mediator pattern is all about a central object which is responsible for interacting with other objects. So the objects don't communicate directly, but they communicate through this central source. And why this is useful? It's useful because you can then put that distribution or maybe that action logic in a central place rather than having it distributed through the individual classes themselves. If we have a look at an example of a mediator pattern, and I do apologize for two things. One is that this is it's Go, which can make a lot of these patterns look quite strange because they were designed to be truly object-oriented patterns, but it's still applicable. And the other thing is that some of this code is a little bit pseudo, so that I can actually fit it on the slide. But the intention behind the mediator pattern is that you have this object which is a party, and this is where all of your sort of your logic would be stored. So when a party member does something, they pass that to the party, and then the party will decide what it should do. Should it notify the other members that are attached to the pattern, or should they just perform a particular singular action? It's also a nice way of passing things down to other objects. So think about things like navigation. If I need an action based on the click in a navigation, or I need to expand it, maybe I need to click on a link and collapse all of the elements which are open, then the mediator pattern is actually really useful for this. The observer pattern. Now, the observer pattern you see all over the place. So a lot of modern systems are built around the observer pattern and observables. Certainly we use it quite heavily. So everything around Drumbeat is indirectly an observer pattern, that you have a central store which is responsible for distributing events to objects which have registered to receive those. And again, using the example of GUIs and controllers, think about that controller action. So we have, for example, a controller and we have a button. When the controller, which is listening to the observable element of a button, when the button is clicked, then the controller can perform an action. And this is kind of like the core principle around the model view controller pattern, or even so chain of responsibility. And I'm going to have to fly through these a little bit quickly, but chain of responsibility is a really useful pattern. So think about it in terms of a layered tier of hierarchy. So think about it in terms of, if you can't handle a request, then you can either pass it down to a subordinate or you can pass it up to a parent. And for those who've ever developed any Objective-C, the Objective-C is heavily based around this form of pattern, whereas every object can receive an event, whereas every object may not act on it. It's to its responsibility to determine what it will do. And event bubbling is a classic example for this. If an event is raised, where do you want to handle it? Do you want to pass it up? Do you want to pass it down? And I think, let's have a look at this example. So what you actually have are, you've got two objects which both conform to the same interface, and you have a boss object and a developer object. So when the boss object handles a request for make tea, it's not going to do that. What does it do? It passes it to the subordinate. However, when the developer object receives a request to complete expenses, it can't do that all on its own. So it has to pass it up to the boss object, which is responsible for authorizing those expenses. So the strategy pattern is quite a useful pattern. And the idea behind the strategy pattern is that you extract elements of logic which is volatile, elements which change quite frequently or quite often, and you get them out of the main body of your code and put them into their own packages, potentially for easy maintenance. If you have a look at how a classic sort of strategy pattern works, it's quite simple in that a class or an object would expect a strategy at instantiation time, and then when it comes to performing an action, it doesn't actually know what that strategy is. It just knows how to execute it. So the decorator pattern. The decorator pattern is also a really useful pattern when you're dealing with things like legacy code, because sometimes you can't change the interface of a code of an object. Sometimes an object has really sort of ugly interfaces, and sometimes you maybe just want to sort of change things around at runtime rather than having to bake them in at compile time. And using the example of a writer, so we have a simple writer and we have a not so simple writer. So when we create an instance of the not so simple writer, what it's actually doing is it's just decorating the simple writer. So when I call write, what I'm actually doing is I'm appending some information to the simple writer before I push it out to the output. And you see this sort of construct quite often when you're looking at things like networking code. So if you ever dig down deep into the libraries, you'll find that a lot of things are based on reader writers, but then you've got string readers, you've got XML readers, JSON readers, and a lot of those are kind of, in some instances, they'll be inheriting, but quite often they'll also just be decorating. Factory pattern. I think this is probably one of the patterns that I use most often, and the intention behind this is that if you're going to create an instance of an object, you don't do it directly. So you don't directly call new. What you actually do is you delegate that responsibility to a factory. And the factory pattern has two different kinds. It's kind of like the sub patterns. You've got the abstract and you've got the factory method. And if we have a look at how the abstract factory works, it's fairly straightforward. So it has two methods which are responsible for creating two other objects, and they're predetermined at compile time. Whereas if we look at the factory method, the factory method is a lot looser. It's sort of, when I want to create an object with a factory method, it just takes any object which is going to then use to determine what spits out at the other side. And if you think about how you could maybe combine a factory method up with a strategy, then you start to get some really nice, really, really loose code. Where I find factories really useful, I find them really useful in tests. So if I need to replace a hard dependency in a test, what I can actually do is I can use my factories to be able to send me a mock example, or I can send a stub or anything like that. Really useful pattern. Singleton pattern, my absolute favorite. And so the singleton pattern has a use, but I don't particularly care for it. And the concept of the singleton pattern is that the singleton pattern always ensures that you only have a single instance of an object. The only way to create the instance of a singleton is through a method. You would never use the new or the sort of the constructor to be able to create that. And it's really useful for things like config. But actually, I think the singleton, as much as I dislike it, does have a use. So back to the concept of testing and back to the concept of techniques like dependency injection. Well, we just looked at factories. So what if we had a factory which was a singleton? So maybe that's not a terrible abuse of the pattern. It would allow us to sort of easily, loosely couple our code right the way through by depending on the singleton, which is actually a factory which produces our objects. Now, the singleton pattern, where you often see it, is you'll see something like this. So you'll have a global variable or a class level variable and a static variable. This is Go, so we don't have static. But then you'll have there's no constructor, but you'll have a method for getting an instance. So in this instance, it's get config. But look at the line of code here. If instance equals nil, instance is config. Now, I'm returning a reference of config. What if I'm running multi-threaded? What if one of my threads is mutating config at the same time as another instance is mutating config? And this is a key thing to be wary of when you're implementing the singleton. You've got to think about multi-threaded, because quite often standard implementation of the singleton pattern, like this one, does not consider multi-threaded access. Adapter pattern. This is terrifically useful in our world of modern big distributed systems. And the reason for that is because we're quite often taking data from somewhere and we want to do something with it. And we might send it on somewhere else. So let's think about an API. So I get data from a database, but my database model is different to my API model. So what do? Well, I could inline write out my sort of output. Or I could use an adapter, and I could let the adapter do the heavy lifting for us. So if you have a look here, then I've got a new API data adapter. And the concept is that this is doing the conversion here for me. So it's taking my database data and it's turning it into something meaningful, which I want to return to outside of my API. Now, this is fully testable. So think about, again, back to testing. If you write adapters and you write unit tests for your adapters, then there's a hell of a lot of logic that you don't have to write in your API controllers. So it's a really nice use of the adapter. The facade. So facade is all about trying to get two things. It's about taking the round peg and driving it into the square hole. And again, it's a useful pattern when we're dealing with distributed systems, because quite often we can't always control that the structure of our object is uniform across the entire of the estate. And the facade's really useful when we have maybe an interface which is incredibly terse, and that's not very useful for us. We want to simplify it. So here, if we have a look at a complex interface which has set name, set person, set age. And if I want to set the name and age of a person, then I have to call 3 methods, which could be particularly verbose. So you can use a facade to define a new interface, which has set name and age on person, and kind of just wraps up those 3 operations for you. Again, it's about making your code simple and easy to read, more so than anything else. And the builder pattern kind of follows along on this theme. And the builder pattern is something which I'm a little bit on the fence with. I think it can be useful. I think whether you use builders or facades, a lot of it's down to like preference and coding style. You find a lot of these builders, they seem to be really popular with Google in their Android operating system. Builders are literally all over the place, and they're really useful for setting up complex objects. So generally what happens with a builder is that a builder, you have a selection of methods which actually return an instance of self. So then you can chain up these operations, and then it's just slid off the edge of the slide there, but at the end of the operation, you then call build, and that returns your object that you want to create. So this, again, could be used because maybe you'll pass the builder across various different functions, and each function will have the responsibility of a particular setup element. In some ways, it can make code nice and easy to read, and it can be nice and sort of convenient to sort of chain things up in this way. Proxy pattern. So the proxy pattern, I guarantee you're using. You'll be using them all over the code that you're writing on a daily basis. And in essence, if you think about what is a proxy, well, a proxy could just be a class which goes and gets some data from a service. So it's wrapping things like an HTTP call, but it's wrapping it up in this nice semantic interface. You can use it to sort of simplify APIs as well. So things which, again, are very, very sort of terse. But also the proxy's got an interesting use case in that you can use it to control the security around an operation. So rather than the code itself, like a block of code determining whether an operation can be performed, you could use a proxy which takes in the requested transformation and the particular privileges of an individual, and the logic you can then put inside the proxy to determine whether that operation is possible. And this is your classic example. So this literally just goes and gets some JSON from an API and returns an object. So I have an object which gets user, and that's all over you'll see that pattern used. Command pattern. So I quite like the command pattern. And I like the command pattern when I've got something quite complicated to do and I want to break it up into little chunks. So what I can do is I can break up my code into these commands. So rather than, it's one step further than just maybe breaking it down into methods. And again, everything's independently testable, which is hugely beneficial because it makes your tests easier to read, it makes your tests simpler. You can see here that we're defining 2 commands. We're defining a command address delete, and we're defining a command user delete. Now, potentially, these commands are actually proxies. So they're going away and they're performing some logic on a remote API. Now, for a user, I don't want to have to tell a user that they have to delete an address before they can delete a user. So what I can do is I can build this up into a command pattern and expose just a single method called delete, which will actually run through and execute all of the commands. So these are some patterns which you'll probably never, ever need to use. I certainly don't think I've really used many of these. But let's take a look at them anyway. So the visitor pattern. So a visitor pattern, according to the Gang of Four, allows you to add new virtual functions to a family of classes without modifying the classes themselves. So already we're reading words into their virtual functions. So we're in a design which is for a very sort of specific language. Never used it. Memento. So about storing and restoring a particular object state. So potentially you could use this. It's, I suppose, potentially like a cache or something, an immutable cache. Never used it. Interpreter. You want to create a programming language? Yeah? Yeah, well, some people maybe do. There's one thing I can honestly say I've never had the desire to do, and that is to create my own programming language. Therefore, I've never used the interpreter pattern. Forget it exists. A bridge pattern, and a bridge pattern is, again, it's about decoupling. I think there's a number of ways that you can do this, and the bridge is not one that I'll ever use. And the prototype, I think the prototype is again, it's based on the factory, but you're getting to quite a sort of a low, sort of a large level of abstraction, and I'm not certain that that's a positive thing. I think in some cases you might need it, but forget that one exists as well. So the state pattern. So basically what the state pattern's all about, and I wasn't sure whether I should put this into the half that you should use or the half that you shouldn't use. But for example, let's think you've got a class, and the class is, I'm thinking of an example off the cuff here, asking me, am I happy? So based on my current state, which is that I'm presenting something to you lovely people, the answer is yes, I'm happy. So I might go and do something like buy you all a beer later. Whereas if you were all heckling me when you throw me a load of interesting and complicated questions after, my internal state might be unhappy. So rather than buy you all a beer later, I might just run off and sulk into a corner. And from the caller, you see, the caller wouldn't have any knowledge of my internal state. It would just be calling the same method. And I think the problem with the state pattern is that it hides too much information. Composite pattern. So this one is all about trees, and I genuinely recommend that you go and read either some Wikipedia on this, and I'm fairly confident you'll come to the conclusion that you never ever want to look at it ever again. So let's just forget about that one too. The iterator you do use. So the iterator you use all of the time for each, when you're looping over a collection. These are all implementations of the iterator pattern, but why I'm stating that you'll never ever use it as such is what I mean is you'll probably never have to implement it. So you won't need to implement it because actually languages these days are so robust and so feature laden that a lot of this hard work is already done for you. If you were down in C, or if you were having to deal with something in C++, then you probably would be dealing with iterators. And the template method. So the template method, again, is more around traditional object-oriented. So it's about creating a class which has deliberately missing pieces. And the intention is that what you would do is you would then write a class which inherits my class, and you would complete the missing pieces. And that could be useful for example, because maybe I've got a login. There's a method, a virtual method on my login class
which is do login. Now, because I don't know what system you're using, you might be using AWS, you might be wanting to do GitHub or anything like that, then actually I'll provide you with the requirement to implement do login, but I'll also require that you actually implement the functionality yourself. Could you do something similar with a strategy pattern rather than having to go to all those levels of abstraction? Yeah, probably. And I personally feel that the code is easier to read and easier to write. Flyweight pattern. And the flyweight pattern, I don't think has a great deal of relevance in today's world, because the flyweight was all about an object which takes a long time to create. So a large object, and I'm talking like, 4K or something here. That what you want to do is you want to kind of cache that in memory, and you want to do part of the computation of instantiating the class, which is slow because it takes 35 nanoseconds, and then reuse that for future iterations. I think you probably don't ever really have the need to use a flyweight anymore. And that's it. So 23 design patterns, some which you will use, some which you are already using, and some which you'll probably never even need to know about. But at least if you're going to read the Gang of Four book, you know which pages to skip. I provided the examples in the slide in Go. The slide deck also has some Java examples, because as I said, the Gang of Four book, 20, 30 years old. So I thought it would be appropriate to put some examples in an ancient language so you can see some of the origins. And thank you, and any questions?
When you mentioned these state patterns, is there anything to do with the state machine that you use? Is that the same pattern, in which case the new pattern?
We do. So we also know that it causes quite a little bit of heartache. So the pattern is used, and that is a very good example of state machine. I think there's potentially better ways to approach that, and I think if you look at the state machine in the Mononoth and maybe try to rewrite it in another way that makes it more explicit as to what's happening at one particular point in time, it's all about trying to surface the logic to a useful location. But yeah, state machines are a good example. I mean, there is. Anybody else? Is anybody wondering why I've not covered any more sort of modern sort of software patterns? And that's because there's an amazing talk coming up, which is looking at more sort of modern architectural patterns, and it kind of follows on these. As I say, these are the basics. These are from the dawn of programming. Thank you very much. Don't be dissing the composite. If you have a natural tree data, for instance, a scene graph, composite is a nice way to iterate. Yes, it is. However, Tony, I've absolutely no intention of trying to implement any software as complicated as Blender, so I won't be using that design pattern. But that isn't actually, that's an incredibly good example. So when you think about 3D graphics, 3D rendering, and the game industry, you'll find a lot of composite patterns in there because you want to try and create neutrality around objects which are inherently different. Thank you.